Welcome! In this lesson, we answer two questions. What is enthalpy? And why, in liquids and solids, is the difference between delta H and delta E usually not significant? First, what is enthalpy? Enthalpy, H, is a thermodynamic state function defined as H equals E plus PV, where E is the internal energy, P is pressure, and V is volume. At constant pressure, the heat flow into the system, Q sub P, equals the change in enthalpy delta H. Now, let's connect delta H and delta E, starting from H equals E plus PV. Take a change. Delta H equals delta E plus delta of PV. Expand that. Delta H equals delta E plus P times delta V plus V times delta P. At constant pressure, delta P equals 0, so we get the key result. Delta H equals delta E plus P times delta V. To see why P times delta V matters for gases but not for liquids and solids, let's visualize compressibility with pistons. On the left, a gas. It compresses a lot, so the volume change can be large. In the middle, a liquid, nearly incompressible. The volume change is tiny. On the right, a solid, even less compressible. The volume change is extremely tiny. Watch the pistons. The gas piston moves noticeably, while the liquid and solid pistons barely move at all. Let's put numbers to this. Under ordinary conditions, pressure is about 1 atmosphere, which is about 1.01 times 10 to the 5 pascals. For many liquid and solid processes, the volume change per mole can be around 10 to the minus 5 cubic meters. Then P times delta V is roughly 1 times 10 to the 5 times 10 to the minus 5, which is about 1 joule per mole. Meanwhile, typical delta E or delta H for chemical processes is in the thousands of joules per mole, sometimes much larger. So the P delta V term is tiny compared to delta E. That is why in liquids and solids, delta H is approximately equal to delta E. Let's synthesize. We derived that delta H equals delta E plus P times delta V at constant pressure. For liquids and solids, delta V is very small, so P times delta V is tiny compared to delta E. Therefore, delta H is approximately equal to delta E in liquids and solids under ordinary conditions. As a final reminder, enthalpy is H equals E plus PV, and at constant pressure, the heat flow equals delta H.